whenever the circle, whatever structure, we just have triangle and hexagon to be done. Maximum they try also to add in quadrilateral, cyclic quadrilateral, but that we will take it later. And whenever you have a circle outside the figure, the given polygon, okay, so there is a triangle over here and the circle is outside it. So this kind of concept is called a circumscribed. You just have to remember whenever the circle is outside, you term this as circumscribed. And in that case, you will be taking the segment bisector or perpendicular bisector of segment. Two at least, because triangles have three sides, right? Pick up any two sides and take the perpendicular bisector. That is the concept for circumscribing. And whenever you have inscribed question, that means if you have a triangle and the circle is inside the triangle, then in this case you will be taking angle bisector. This knowledge is sufficient for you to do almost all the questions of circumscribe and inscribe. You are supposed to circumscribe a circle. Write the question. A circle around a circle around an equilateral triangle measuring, let's say, of segment 4.5. 4.5. So what we need to do first is to make the triangle. Okay, first process is to make the triangle and then you're going to be adding the circle to it. So this is very simple. 4.5, take a base. We have just done this as the very first construction for today. And use the compass, okay, and don't use scale. A lot of children do this. They take 4.5 and they do this kind of adjustment from both the ends. And this is always going to go wrong when you do construction directly using scale and trying to fix up, and it wastes a lot of time in doing the adjustment. Rather use compass. Take 4.5. Let's say this is B and this is C. Place it at B, cut 4.5. Place at C, moving the compass so they will be crossing each other at the same measurement. And first join this. Your triangle is ready. You can call this as A. Okay. So once this is done, then tell me. Now you can pick up any two side. It can be AB, BC, or AC, BC. BC will be there because that is very easy for us to make construction. Perpendicular bisector. Now, so between B and C, you want a bisector. So place the compass at B. Take more than half. Take a cut on the top and the bottom. Don't move the compass. Place it at C. Cut the previous arc. Wherever they meet, that is going to be a perpendicular bisector. Now don't move it because it's an equilateral triangle. Don't move the compass. Half of the work is sorted. I'm making it over AC. You can also try with AB. You will get the same result. I mean, even that technically is a centroid that you are trying to take it, but any two sides is sufficient. And when you do the construction for C over here, you can also make on the right side, so you're saving your time. So on C, you will make a cut. The same cut actually goes on the same path. And don't move the compass. Place it at A and cut the previous arc and the arc before it. So it mostly will be lying onto the same point. So let me say for A, the cut is going this way. The cut might go this way. And try to join this. Okay, so roughly I'm doing this. And wherever these two bisectors are going to meet, mark it as O because that will be the center of the circle that you're going to construct. So do till this part where you take this O as the center and extend your this pencil to any one of the vertex. We can prefer taking this A. So keeping O as the center till this A, you will be fixing your compass needle, and you will obviously see that the circle will pass through B as well as C. And keeping A as your point, this is how the circle will be formed. And this kind of structure is the circumscribing a circle. So whenever circle is to be drawn outside the figure, you are considering the segment bisector, perpendicular bisector. Take any two segments, form the bisector. Wherever they meet, keep the compass there, extend it to one of the vertex, and then draw the circle. Okay, and everyone will check what is the radius of this, radius of the circle. Like while you have done the extension, okay, don't move the compass, take the compass, keep it on the scale and check the reading. What is the measurement of radius? Also give you the inscribed one. For inscribed, what you need to do, suppose you have to inscribe a circle around, let's say, an equilateral triangle. And let me take that equilateral triangle. It's not that they will always give you equilateral triangle. I'm just taking this for convenience so that we understand the concept first, and then we can have variations in the question. So 5.6, everyone will do this. Take 5.6 as your segment, base segment, call that as BC. If the names are not given for the triangle, you can give it, but write it. All the steps of construction is also important. So write it down simultaneously. And take 5.6 on the scale, make the cut from B, make the first cut from C, make the second cut, and join them. This is your equilateral triangle ready. Okay, 6 equilateral triangle is ready. I hope that. So 5.6, I'm just writing the measurement. This is A, B, C. Now for inscribe, what you need to do, you have to do angle bisector. Mostly take the base angles, that is B and C. As I've said, they are more better rather than taking A. Now, how do you do angle bisector? We have done that. I'm just giving a quick summary of it. Place it at D, the compass, and make an arc this way. Don't move it. It's an equilateral triangle, so no need to move it. C and make the arc. You're doing angle bisector. Then here you have to do a little adjustment. So this point that is there, let me call this D, and this point over here E. At D, you're going to keep the compass, and this is that angle for which you have to do the bisection, right? So have an idea that almost this much is half. Try to just take more than half of the angle. You don't want this big. Within this range, this is your complete angle. Just shorten it up a little bit. Don't take complete angle, just give a little less angle. Place it at D, make the arc, and let me say this as F and this as G. Okay, place it at F, don't move the compass, and cut that previous arc. And don't move the compass at all. You have done this adjustment, it will work correctly on that side also because it's an equilateral triangle. No have to do the readjustment. So keep it at E, make the arc. Same thing at G, make the arc. And they're going to meet somewhere, right? So they will meet like this. I'm just roughly drawing it. So one angle bisector and the second angle bisector. They will meet, let's say, at O. This will be called as O. Your work is not done, and don't mess up with circumscribe and inscribe. You don't think that you got the O and your work is done, that you connected to the vertex. No, that will form a different thing. Now, that will not even be connecting all the ABC. Now, one more step you have to do extra with inscribed question is, from this O, you have to draw this perpendicular bisector. Okay, and that will fall at this point, and you will call, let me say that as P. And this OP is very important because your OP is going to work like the radius of the in circle. So how do you construct a perpendicular bisector from an external point? I'll give you the idea here. Suppose this is the base of it. There's a point here. From here you have to draw 90 degree. Don't use scale and don't use protractor. That's the main thing here. So what you have to do, keep your compass needle at that point from where you want to draw a bisector and make a cut like this. Okay, extend it such a way, and of course, if I'm going to give you a very big triangle, it would be adjustable with your compass. So keep it at O and make an arc in such a way that it cuts through BC. Okay, this work I'm also showing it on this side. So once you have done this, then that's the same thing. Just flip your book. That works like a semicircle. We know how to do construction of 90 degrees. Then you can take any one point. I'm taking this point for my reference, and let me call that as S. Now, place your compass here. Now, you all know how to do 90-degree, right? Your first cut will be 60, your second cut will be 120, and between these two, you're going to form 90-degree. Yes, so that is how it will look like. First cut, second cut, and then once this is intersecting, directly join. Suppose this is your intersection point, directly join that arc. Okay, and that is going to be falling exactly at 90 degrees. This is the construction extra for inscribed. So once you are done with the angle bisector, it will meet at O. Your work is not done there. From there, make an arc on BC, most probably the opposite side, and from this point, you make that construction of 60 cut, 120 cut, then 90 degree, and join this any measurement. It's just that it should not be too large that it's going out. It should be sufficient that it's cutting through the segment. Okay, there is no condition for measurement. Do till this step, and then only one last step is left. So keep the compass at O and extend till this point D, wherever this 90 degrees meeting. This we've already called as D. No, sorry, P. From O till P, do the correct adjustment, and directly you're going to draw the circle, and that circle will be a circle that will be inside the triangle.